let's begin. So, what I'm going to do today, I'll cover three things today. So I'm going to cover quotient rule, product rule, and then I'm just going to go back onto the rule that you copied last session, the derivatives of your circular functions. So for example, derivative sine, derivative cos, derivative of tan, and the main thing that you need to be able to take that extra step is to know your exact values. For example, sine of pi 6, cos of pi 4. You need to know these values off by heart in order to answer the question fully. So that's why I'm going to revise your exact values, okay? And then I'm going to do quotient rule, product rule, along with your derivative. So that should knock down exercises 9G, H, I, J, and K. So you're using chain rule for every one of them, okay? Now today's one, in product rule and quotient rule, just to try to familiarize yourselves, I've got these questions here, which I'll put on Schoology as well, but I've just selected just the last 2 years, and I'm showing you, you know how I told you that your first question of your first exam, it's likely to be a product rule, quotient, or chain, and I'm just showing you that in 2 years so far, it's 2 marks each time. It's the easiest things that you can expect to come up. It was last year, it was the year before, and I promise you, if you just keep flicking through it, you'll find there's got to be one of those for every year. So you're not doing yourself a favor if you can't do chain rule, if you can't do product rule, you can't do quotient rule, you can't tell the difference between them, you're not doing yourself a favor. 2 marks out of 40 is easy to achieve, yeah? So that's why I want to make sure that you're going to learn how to do, and I'm going to then show you this Excel spreadsheet that Mr. Stefano made before she's gone on maternity leave. This is a really nice one. What she's done last year, she's composed all the years from 2017 all the way down to, I think, maybe up until where the course changes. So 2007, what she's done there is for every question, she's linked it to the exercise that you're doing in your textbook. Okay, so for example, 9J is your product rule. So you want to know which years. I normally do Control F instead of scrolling down. I type in 9J and I press next, and it'll take me to 9J. So I can already see 2014 short answer question means exam 1, question 1A, 9J, product rule. Okay, you can look at that. So every skill that you've learnt in chapter 1, chapter 2, whatever, you can sort of find and see how it's relevant and what examples there are. I think that might be useful throughout the year or towards the end of the year or when you're sort of cramming to study. I think it's useful to have. So I'm going to post that up to Schoology as well, just for you to have a look if you want to look at them. Yeah. So the 3 questions that I've taken from, I've just looked at this and I found them on there. Yeah. Some of the resources you might not have access to at the moment, you can search on Google. Most of them are on VCAP, unless they're a special type of exam. But I'm pretty sure the ones she's gone through is just VCAP. So nothing to do with MAV, nothing to do with other companies. All right? But that'll be a good resource just for you to use to find out your past exam questions relevant to the exercise you're doing. Yeah? All right, so let's have a look at your exact values today. That's where we're going to start off. Circular functions. For those who were in my class last year, would have remembered this hand method. If you weren't, then I'm going to teach it to you now. I'll teach it to you now. It's a bit hard because on this, you can't really record my hand. So when I'm recording it, you might find it a bit weird to understand. So those who are watching, just sort of do it, if that makes sense. All right, here we go. We are going to start off with, these are the exact values that you need to memorize. There's a lot of ways to remember. A lot of kids remember through the triangles, or they sort of notice there's a pattern 0, 1, 1, and then, actually, sorry, it was all out of 2s. Okay, and then you can sort of go through, you see that there's a sort of pattern. You go from, normally that's a 2 over root 2. It normally seems 1, 2, 3, 4. I like to show you this method. Now this one here, the first one is on YouTube. If you sort of forget it, you can find that one on YouTube. But the next one I made up. Okay, so for tan, I made this one up. Okay, so here we go. How do we use this hand method? On your 5 fingers, you don't have to draw it like I did. Okay. It is my hand. My calluses back in the day they used to live. But now I don't anymore, so this is right. Here we go. So we got 0, pi on 6, pi on 4, pi on 3, and pi on 2. Those represent the angles from smallest to largest. Okay, a lot of people have sort of troubles moving between radians to degrees, and so pi on 6, not a lot of us know it's 30 degrees, but if you remember it as smallest to largest, from your left to right, smallest to largest, then it's 30 degrees, 45, 60, 90. Yeah? In order to memorize this, the first rule that you get in the center of the palm, that's a rule, square root, and it's blank, divided by 2. Yeah? That formula only works for sine and cosine. Right? If you want to find 10, I've got my own rule for that one. But here we go. How does it work? Notice I wrote sine on the left-hand side of my palm and cos on the right-hand side of my palm. So from here, if I want to find, let's say, sine of 30 degrees, the answer is half. Well, let's show how it works. So on your palm, you look for the finger that represents 30 degrees. So which finger is that? What's that finger called? The index finger. Yeah, so my index finger, which is pi on 6, I'm going to drop that finger down. Okay, so right now I've only got 4 available. Now what you see is it creates this, so once it goes down, you've got 1 finger on the left-hand side, which is your thumb, and then you've got 3 fingers on the right-hand side. Now if I'm saying sine, I count the number of fingers I have for sine. Sine's on the left. Cos is meant to be on the right-hand side, right? So on the left-hand side, I've got 1. So in the formula, so if you're looking at the formula, I'm sort of saying, all right, I've got root of how many sine fingers I have. So if I drop this one down, I only got 1 sine finger. So I'd say root of 1 over 2. Now we know that root of 1 is 1, and over 2, that gives us the answer of half. So hence, sine of pi on 6 is half. Well then what if I say cos of pi on 6? See, if I say cos, whoops, how do I get this out? Yeah. Cos of pi on 6, then on pi on 6 is the same finger. It's still your index finger. So I drop down my index finger, and then I look at it and I say, well, how many cos fingers do I have? Now notice cos is meant to be the number of fingers on the right-hand side. So if I count the number of fingers on the right-hand side, I've got 1, 2, and 3. That's on the right-hand side of pi on 6. So therefore, I'd say, all right, well, in my formula, I would then have root of 3 on 2, and that just gives me root 3 on 2, which makes sense because cos of 30 degrees is root 3 on 2. Okay, and you can do this for every single finger. So let's try now. What you've just learned, if you understand that formula and how it works, you technically memorize the first, what's that? 4, 5, 10. Okay, so you memorize the first 10. If you try, let's say, sine of 60 degrees, so 60 degrees, which finger is that? Which finger is that representing 60 degrees? My ring finger, yeah, pi on 3. So I'm going to drop down the pi on 3. Now if I'm looking for sine, how many fingers are in this left-hand region or the sine region? I've got 3. Okay, so if I drop down, I'm going to draw it again on the screen. Pi on 3 is my 60 degrees, so I drop that one down. I count the number of fingers on my sine. Clearly I've got 3. Okay, so that's on the left-hand side. So I've got 3 fingers, and same thing again. The answer for sine is square root of number of fingers for sine 3 over 2. And that gives me sine of 60 degrees. That's true. If I want to do, let's say, sine of 90 degrees now. So 90 degrees, I drop down the pinky. I drop down my pinky, and I count number of fingers I have on the left-hand side. In this case here, I have 1, 2, 3, and 4. So if I want to know what sine of 90 degrees is, then I will count those fingers. I say there's 4, but root of 4 we know is 2. So therefore 2 divided by 2 is 1, which makes sense. Sine of 90 degrees is 1. Okay. What do you do if it's cos? So for example, if I said cos of 90 degrees, well, if you think about it, on the right-hand side, I don't have any extra fingers unless you do have 6 fingers. Most of us have 5, right? So after that, you say, well, there's 0 fingers for cosine, so therefore root of 0 is 0. 0 divided by 2 is 0, which makes sense. Cos of 90 degrees is 0. Does that make sense so far? How do we feel about that rule? Yeah? So this only works for sine and cosine. Square root of the number of fingers you have, and then divide that by 2, or half it. Okay? Now for tan, so even if you forget this one, you can watch this video again, or you can watch on YouTube, and there's a lot of ways to sort of memorize those sine and cosine. But this one here, I made up. Okay, so this rule for tan, same thing, 0 degrees all the way to pi 6, pi 4, pi 3, pi 2. Everything's the same. The only thing that changes is the formula. Now we all know tan is sine over cos. Okay, we know the properties for tan is sine of theta over cos of theta. It's the same thing here. The only difference is you'll be finding the number of fingers for sine over the number of fingers for cos, and then you square root that answer. That's the only difference. Okay, so here we go. How do we do this? Let's say I want to find tan of 30 degrees, right? The answer should be 1 and root 3. So let's have a go. I'm going to go drop down my index finger. Tan is meant to be the number of sine fingers divided by the number of cos fingers. So number of sine fingers I have is on the left-hand side. There's 1 finger here. So I say 1 over the number of cos fingers I have 1, 2, and 3. So you can say it's 1 out of 3. But remember, the formula is once you got that ratio, square root it. So if I square root them, I know that it's the same thing as writing root 1, root 3. So that becomes 1, root 3, which is correct. Okay. If you want to do tan of 45 degrees, for example, say tan of 45 degrees, drop down the middle finger. You now say number of sine fingers divided by number of cos fingers. So you got 2 fingers for your sine, so you can see there's 1, 2. So you say there's 2 fingers for sine, count number of fingers for cos. There's again 1, 2, so therefore it's 2 out of 2, and then square root that answer. Now root 2 on 2 is the same thing as saying root of 1, which is 1. Makes sense. Does that make sense so far? Cool, so you only got 2 rules. For tan, it's sine over cos, square root it. Sine and cos, it's square root the number of fingers and divided by 2. Okay, so those are the 2 things you need to write down. You don't have to use this rule, remember, I'm just trying to help you another way to memorize your exact values, because you need them, just like your times tables, you need them in order to answer the question. Especially one of the exam questions I've chosen, they want you to know what cos of pi 4 is or tan of pi 2 is. You have to be able to figure that out. Okay? How do we feel with that? It's all right, because what I'm going to do is I'm going to give you a test. Yeah, I'm going to call out each and every one of you, and I'm going to give you a random one. I might say sine of 30, I might say tan of pi 6. You have to be able to figure out what the answer is and let me know. Yeah? All right, let's try this. Sine of 30 degrees. Aaron, what is sine of 30 degrees?
1 on root 2.
No. So the formula for it was square root the number of fingers you have for sine and then divided by 2. So how many fingers do I have for sine?
1.
Good. So root of 1 is?
Oh, my bad. 1.
Just 1. So it's 1 out of 2. So it's half. Okay, so we got half. Good. Next one, tan of 45 degrees. Will? 1. Okay, same thing again. You can count the number of sine fingers you have, which is 2. Number of cos fingers, 2. Square root the answer. So root of 1 is 1. What is cos of pi 6? Can I please, Marzin? Fantastic. The answer is root 3 over 2. So you got, drop down the index finger. You got 3 fingers for the cos, and then divide that by 2. So root 3 on 2. Next one, tan of 30 degrees. Can I please have Jordan? What's tan of 30?
1 on root 3.
1 on root 3 is correct. Drop down your index finger, and you got 1 for sine, 3 for cos. Square root both those answers. Square root of 1 is 1. So you get 1 on root 3. Next one, sine of pi 2. Steph?
1.
1 is correct. Cos of pi 4. Sion? Good. Root 2 on 2, or in your text, they normally say 1 on root 2. Either way is fine. Okay, so you can have root 2 on 2 or 1 on root 2, whether you want to rationalize the denominator. Yeah? Next one, tan of pi 2, Liam. Say it again. Undefined is correct, because we know number of sine fingers we have is 4, number of cos fingers is 0, but then we know that 4 divided by 0 is undefined. Okay, let's continue. Trent, what is tan of pi on 3? Root 3 on 1, which is the same thing as saying? I'll write it again. Root 3 on 1 is the same thing as saying? Root 3, fantastic. Okay, so we've got root 3. What is the cos of pi on 6, Shirley? Cos of pi on 6. Good, excellent. Rose, what is cos of pi on 3 then? 1 on, yes, half is correct. Athena, what is sine of 0? No. So which finger would be my 0 degrees? Yep, your thumb. So I drop it down. Now number of fingers on the left-hand side of that thumb. None. So you would say square root of the number of fingers you have and then divide that by 2, which is? No, 0 divided by 2. 0. 0 divided by anything is 0. So 0 divided by 2 is 0. Okay, square root of 0 is 0. And then 0 divided by 2 is 0. Richie, what is cos of pi on 2? 0. Cos of pi on 2 is 0. Same logic. Number of cos fingers on the right-hand side is 0. So 0 divided by 2 is 0. Verity, what is tan of 0? No.
No, that's 0.
That's 0. Yes. So it's the other way. Number of sine fingers 0 divided by 4. So 0 on 4. Square root that. That gives you 0. So tan of 0 is 0. Monica, what is tan of 45 degrees? One is correct. What is, have I chosen everyone here? Ian, what is sine of 60 degrees? Root 3 over 2 is correct. Michael, what is cos of pi on 4? Say it again? Not too sure. So which finger is my pi on 4 or 45 degrees? Look at the picture. Actually, there's no picture. I'll go back to this finger here. Don't look at the chart. Look at the finger. Which finger do I have? What's my pi on 4? It's the middle. Good. So middle finger goes down. Now I want to find cos. So cos is the number of fingers on the right-hand side. How many fingers do I have? Yes, you have root 2 and 2, or as you can say, 1 on root 2. How do we feel? Do we generally got the idea of how it works? Good? Excellent. Now we'll move back to what you need to know, how to find the derivative and then hence sub in the values. Yeah, that's what exercise 9I is about. 9I circular functions. Okay, so let's revise what we learned in the last session. I asked you to copy a few things, yeah? I said y equals sine of, let's say, x, and then you had y equals cos of x, and then you had y equals tan of x. So let's find, what was the derivative formulas again when I asked you to copy this down? So let's have a look. dy dx. What's the derivative of sine? Again, can I please have Aaron? What's the derivative of sine? What's the formula?
Oh, that's like it's related to cos.
Yep, I just want the rule. So last session I got you to copy a couple of rules. We're just revising on the rules now. So if I had sine of x, derivative of sine of x has to be cos of x. I'm going to write it in red actually. You got cos of x. What is the derivative of cos of x? Can I please have, let's go with Richie. Negative sine of x. You got negative sine of x. And then what is the derivative of tan of x? Can I please have, let's go with Mazen. Not sure. Trent? True, that's where the rule comes from actually. If you use question rule to sort of figure this one out. Good. It is sec squared of x, or, which is, sec squared is second. That's what it means, the second. And that means 1 over cos squared of x. If you're wondering what the squared means, it really just means 1 over whatever cos of x is, and you square it. Okay, that's what it actually means. Okay, so derivative of tan, that comes from your quotient rule where the proof comes from, but you're expected to know these 3 rules. Okay, so you need to know what derivative sine of x is, derivative cos of x is, derivative tan of x. Now, exercise 9I, we'll practice these 3 skills using chain rule. So remember, this is all you know. If you get anything different from that, you got to use chain rule to figure it out. So let's do an example. I'm going to give you a couple examples here, okay? So let's say I give you y is equal to 2 times sine of 3x squared. Okay? Actually, maybe I'll take off the 2 so that you don't get confused for now. All right, so y equals sine of 3x squared. If we compare that to the rule that we have, it is different because I only know sine of x. I don't know what sine of x squared is. I don't know what sine of 3x squared is. I just know the derivative of sine of x is cos of x. So what's the issue here? What do I want to replace? What's the thing that I want to replace, Will? The sine, yes, within the sine is what I want to replace. Yeah, because I know what the sine of sine of x is. What I don't know is sine of 3x squared. So what the issue is I can't do this problem because I've got the 3x squared. But if I had one variable, if I change that to something that is more familiar, so let's say I said, let u equal to 3x squared. See, I'm using chain rule again. If I let that equal to u, how does it change the problem? It changes it to y now becomes sine of u. Now that's something I know, because that's very familiar or similar to the rule I have up here. That's y equals sine of x minus y equals sine of u. So naturally, dy dx is cos of x, so then dy du has to be cos of u. Yes. So that's why I know this is nice, because I can say dy du must be cos of u based on our rule up here. That's based on the rule up here. So that was nice. But remember, when you're using chain rule, you find dy du, you also need to find du dx. So right here, you got the change of u, so du dx. What's the derivative of 3x squared, Mazen? 6x, fantastic. So now I'm going to use the chain rule. The chain rule says dy dx is equivalent to whatever dy du is multiplied to du dx. This is your chain rule. And we know this because du times the du on the denominator, these two will cancel out. So if we write it out, dy du was cos of u. That's what we figured out. And du dx, we know, is 6x. So if I put them all together, I say, all right, well, that means the answer has to be 6x multiplied to cos of u. Now, am I done? That's dy dx. Am I done? No. Why? What have I done wrong? What's the issue? What's the problem? Mazen? Good. See, I said it's relationship between the change of y and the change of x. I didn't say anything about u. U is a made-up variable. I made it up so that it works easier for me. So I have to replace that u, and I said up here before, I said let u equal to 3x squared. So my answer should actually be 6x cos of 3x squared. How do we feel about that? Does that make sense of what I'm doing there? Okay, so that's the same for cosine, that's the same for tan. You get these 3 basic rules above here, and your job is to try to work with chain rule. Eventually, you don't have to do the steps I'm showing you here. You find the derivative of the inside, so 6x times the derivative of sine, cos of 3x squared, multiply them together. But I'm just showing you how you can use chain rule, because they happen all the time. Okay? Feel good? Excellent. All right, let's do a couple more examples. I'm going to go back to the slides, and let's go through some examples so that we feel a bit more confident. So these are our rules. Let's have a look at these. Let's try let's try F. Okay, let's push our understanding a bit. Let's do F. F is y is equal to cos of x squared plus 1. Now obviously, I don't know what cos of x squared plus 1 is. I only know cos of x. What's the issue? What am I replacing? What am I going to replace? Michael? Good, I replace x squared plus 1. I'm going to call that u. So this is the issue here. Oh, whoa. The issue is the x squared plus 1. So I'm going to replace that. I'm going to highlight it first. This is the issue. So I'm going to replace that with another letter. And I say, well, why don't I call that something else? Let's call that u equals 2x squared plus 1. What's the benefit of doing that? It changes the problem to y equals to cos of u. That's something I know. That's very similar to the rule I have up here. So I know that that means the derivative dy du has to equal to what? Negative sine u. So negative sine of u. But then I also need du dx. So let's work it out. Du dx, if I know that u is equal to x squared plus 1, derivative of x squared plus 1, which is 2x. Put them both together. Chain rule tells me then, therefore, dy dx must equal to 2x multiplied to the negative sine of u, which is x squared plus 1. Okay, so you normally just write your answer as negative 2x sine x squared plus 1. Is that easy? Okay, so we're just sticking with the chain rule. They give you different ways of doing them. So you can see how they vary the problem. They go from sine of 5x to plus 5x, tan of 5x, and then they start putting squares in. Now I'm more interested in the ones, so you can do the ones where you have x squared inside the brackets. What do you do if you have, let's say, both? Okay, so let's go with the I or J. Which one do you prefer, I or J? I? Let's do I. Okay, so let's try I. We're going to do I. Got I here says y is equal to sine, all cubed, so cubed of sine of 2x plus pi and 6. What that little 3 actually means, another way of looking at it is like this. It's just saying whatever sine of 2x plus pi and 6 is, I'm going to take that answer and I'm going to cube it. That's what it's trying to say. Okay, so this looks different to what you were used to before. It's different to cos of x squared plus 1. You replace x squared plus 1 because it was cos. What would you be replacing here? What's the issue? You're replacing the? Yeah. See, the reason why is because this overall is actually a cubic function. If I took this whole thing off, I've got something cubed. So that makes it nice because I can use power rule for that. So it's a chain rule, but it's a reverse one. So you've got to be able to tell the difference when you replace the inside or you replace the outside. So here, I'm going to highlight again. You are replacing the entire inside because this tells me that I've got a cubic problem, which I'm going to do in red here. If I let this equal to u equals to sine of 2x plus pi and 6, then how does that change my problem? Y now becomes y equals to u all cubed. Because I replaced the entire function there, so it makes it nicer. I've just got u cubed. And that's easy because I know dy du has to equal to what? What's the derivative of u cubed? 3u squared. So you got 3u squared. Now here's the tricky part. You need to find du dx. And that's what I mean. At the year 12 level, you are expected to find the chain rule quickly. So you're not meant to be doing what I'm showing you over here because it takes too long to do. I'm just showing you how it works from last year. And now this year, you're meant to be able to look at this and say what the answer is. Now we know the derivative sine itself should give us a cos. But remember, the issue now is this 2x plus pi 6 is not x. So again, you have to use a double chain rule. So not only did we just do a chain rule just now, now we've got to do another chain rule. That's why it looks messy. But at this point, if you check your examiner's reports, they expect you to be able to tell me the answer. So here, they would say you'll be finding the derivative of the inside, because that's what you're replacing. And you know the derivative sine already. So the answer, which I'll write out in one go, should be this. I'm going to do it in green. Derivative sine, I know it's cos of whatever the inside is. So that should be cos of 2x plus pi and 6. Multiplied 2, now I have to find the derivative of what I'm replacing inside. So derivative 2x plus pi and 6, 2. Fantastic, because 2x plus pi and 6, a lot of kids get confused because of the pi and 6. Remember, pi and 6 is just a number. It's like saying derivative of 2x plus 1. You would say, well, 1 becomes 0, and then derivative of 2x is just 2. Okay, so I now know the derivative of the inside should be 2. And that's the expectation at this point, that when you do the chain rule, you can find the derivative of sine of 2x plus pi and 6. You should be able to look at this and say derivative of 5x is 5 times the derivative of sine, which is cos of 5x. And that's your answer, 5 times cos of 5x. Next one, if you were to do tan of 5x, you're meant to know the derivative of the inside is, again, 5 times the derivative of tan, sec squared of 5x. See how I'm doing it? And the technique that they call that is sort of like derive the inside, derive the outside. That's what chain rule is. And the expectation is you are meant to be able to tell me the answer the way I just did. Okay? So now, putting them both together, you got dy dx has to equal to 3u squared multiplied 2 du dx, which is 2 cos of 2x plus pi and 6. Okay? U squared, we know u was replaced with sine, so it looks messy here, but this is your answer. You got 3 times 2, which is 6. U, which was sine squared of 2x plus pi and 6, and then times that with cos of 2x plus pi and 6. There we go. Looks terrible, but that's the expectation that you're going to go through. Okay, this was a double chain rule, but over time, you should be able to look at this and say derivative of the inside, 2x, times derivative of cos, negative sine. Okay, so that's exercise 9I. Easy. Some of the questions will then say, remember I said there's only a few things you're going to do. You're going to find the gradient. Find the gradient, you need a point. So in exercise 9I, they will tell you to find at a point, and unless you know your exact values, you won't be able to finish off the question. Yeah, so the derivative only gives you the gradient function until you get a point that then tells you what the gradient is equal to. Okay? Sorry. All right. Oh no, it's crazy. All right, here we go. Let's find one where it has a point. No, it doesn't have a point. Oh well. Let's teach you the product rule first, and let me just check if there's a sine one in this one. No, you need to know the quotient rule. All right, that's all right. Okay, here we go. Was that an all right breather? That was exercise 9I. Good. All right, 9J. I want you to copy my formula up here, because in that particular order as well. Okay, the reason why is because when you're adding, it actually doesn't matter if it's UV dash and VU dash. A lot of students will do UV dash because the first one is U dot V. Okay, U dot V means times. U times V. And so naturally when you write your rule, you do U dot V dash plus V dot U dash. I don't want you to do it that way. I want you to do VU dash plus U dash V. I mean UV dash, yeah? What I'm trying to say is do Victoria University first. Okay, VU. VU first. Okay, VU first. So I want Victoria University first all the time. Why? Because that will remind you what quotient rule should be. Because quotient rule is actually very similar. Let's say I'll do Q of X here. Quotient rule is U divided by V, and then Q dash X, which is the derivative, is equal to, it's the same thing, V U dash, instead of plus, it's minus U V dash. Okay, that's why I want you to remember the product rule in that particular order, because then it'll help you remember quotient rule. Otherwise, you normally mix it up, and that's where the mistake comes in. Like when students make a mistake with quotient rule, it's because of that. Yeah, because it matters when you minus, it doesn't matter when you add. That's why you got to remember in this order. It's VU dash minus UV dash over, anyone remember? V squared. Okay, this is your quotient rule, and we're going to work through an example from both so that you get a feel of how to do them, and then I'm going to give you this worksheet. We're going to have a go at them, and then we're going to go through the answers together for this double session. Okay, so let's do product rule first. Product means times. Quotient means divide. So anytime you see division, you'll be using Q of X or the quotient rule formula. Anytime you see multiplication, you'll be doing product rule. Okay, so let's do a product rule problem. How is it different to chain rule? Actually, that's one of the exam questions. Oh, well, you're going to do it anyway. It's on your sheet. There you go. How do you know this is not a chain rule? A lot of students get confused between the two. As long as you know you've got two things multiplied to each other, it is a product rule. If you have a function within a function, so for example, if I gave you log e of x cubed, see that is a chain rule. If I gave you x cubed times log e of x, that's a product rule. If I gave you x cubed over log e of x, that's a quotient rule. Okay, so let's give you a couple of examples and I want you to tell me which one is chain rule, quotient, and product. Yeah? So let's have a go with these ones. A. Let's do sine of x, cos of x. What kind of rule is this one? Product, because you got sine of x times, when you write it next to another function, it's times. So this is product rule. Okay, let's try B. What if I did 2 sine of x squared? Yeah, 2 sine of x squared. This is chain rule, okay? Because I've got an x squared within sine of x. I'm not multiplying anything. Okay, there is no product rule here besides the 2. That's a constant, so it's not a function. It can be a function. You can use product rule if you want, but 2 you can ignore at this point. Yeah? Let's try another one. Let's say if I gave you c e to the x squared plus 2. What's this one? Chain rule. This is chain rule. This is chain rule. If I gave you now d, let's say e to the x dot e to the negative 2x. What is this? Product rule or quotient rule? Up to you. Okay, so you can write this one as product rule because it's multiplication of two functions, or you can think of it as e to the x over, or multiplied to 1 over e 2x. You can think of it that way. So it becomes e to the x over e to the 2x. That could be a quotient rule. So if you write it like this, quotient rule. If you write it like this, product rule. Can we see the differences now? Yeah, because at the end of the year on your SAC, I don't want to see a mistake with that. Every year I get a couple of students who will confuse product rule. So product rule will be this one, the chain rule. Chain rule is the one within. Product is when you have two things multiplied to each other, 2 or 3 more, and then quotient is when you divide. Quotient's always been easy for a lot of students to know that's quotient. Problem with that is they get their formula wrong. Okay, so it's like, yes, I know it's quotient, and then when they go to do the fractions, they screw up. The students hate fractions. Yeah, so that's why quotient rule in the last 2-3 years now it's been coming up. Quotient rule for last year, quotient rule for the year before has come up. Okay, that's your first question. So learn the quotient rule, learn the product rule. Previous years to that, it was chain rule. Chain rule is the difficult one where a lot of kids have problems, but I know it's going to be one of those 3 for your first 2 marks in exam 1. So learn it. Yeah, learn those 3. It's going to come up for sure. Yeah? All right. Now, so how do we do this problem? Now that we know this is an x multiplied to a log e of x, so I know it's a product rule. This is what product rule says. U dot v. So how do you use the rule? You simply say, all right, I'm going to call the first letter or first function u, and my first one is x. So I'm going to call it u, because that's what's over here, u. Dot, which means times with the second function, which is log e, so I'm going to call that v, and I'm going to find the derivative of each one. So derivative of x was 1, derivative of v, what's the derivative of log e x again? What's the rule? 1 on x. So I know v dash is 1 on x. So how do you put the answers together? The answer is, remember, Victoria University first. Yeah, Victoria University first, VU. So in this case here, it's v times u dash. Okay, so then add on u times v dash. So if you work that out, it's log e of x multiplied to u dash, so log e of x multiplied to u dash, plus x times 1 on x. Put down the answer. You should have log e of x becomes log e of x there, and x times 1 and x divided by x cancels out to be 1, so you get 1. Did you know that was one of the exam questions? Question 1 of the years. I think it was either last year's one or the year before that, 2016 or 2015. It's a very easy question, and it's only answered 80% of the time, which is like, what happened to the other 20%? Yeah, and that's what I mean. When you get below 25, you're sitting in that range. Okay, if you get below 25 raw, the reason why is because you're one of those 20% of people who can't do a quotient rule or product rule properly. Yeah, they're trying to give you marks. Exam 1, they're literally trying to throw you marks all over the place. They're hoping you to get as much as you can, and they knock you down in exam 2. Yeah, it literally is. They literally try to knock you down in exam 2. So exam 1 is your goal to ace as many marks as you can. You're meant to walk out of exam 1 going, I ace methods, not, oh, I don't know. Because if you're walking out saying, I don't know, then exam 2, you just might as well give up. You know, just lie down on the ground. So exam 1 is literally giving you all the marks. Okay, so practice the basics. If you can't do exam 1, you're looking below 25 raw. That's just generally how it works. Okay, if you can't do exam 1, it's below 25. That's just how it is. Yeah? All right, here we go. Next one. What kind of rule do I have here? X tan of x. What kind of problem do I have? How do I find the derivative? It says find the derivative. Y equals x times tan of x. What kind of rule am I using? Chain, product, or quotient? What's that, Liam? Product. Again, same idea again. It's not within. It's not a function within. It's two separate ones. X is a linear. Tan of x is a circular. So when you multiply those two together using products. So again, I'm going to use the rule. Got to define u, got to define v. U is the first one, v is the second one. So in my case here, same drill. U is my x. Derivative of x is 1. Next one, v is my tan. What's the derivative of tan of x again? What's the rule? Sec squared of x. Here we go. Put them both together. Remember Victoria University first. VU dash plus UV dash, right? So I'm going to follow that rule. Is what I get. Tan of x times 1 is tan of x. X times sec squared of x. I get my second term. Now the question says evaluate the derivative when x equals to pi and 6. In exams, that question there, a lot of kids forget to do the next part. Because they're so hyped up on getting this answer like, yes, I'm done. You're not done. This is a 3-mark question. That's 1 mark, 2 marks for that exam. 3 marks out of 40, that's pretty good. They're really throwing it out at you. Just 1 skill is all you have to do. And 1 exact value. Yeah? So now pi and 6, you have to find out the value to this. You've got now dy dx at pi on 6. When x equals pi and 6, you've got tan of pi and 6 plus, now remember x is pi and 6, multiplied to sec squared of pi and 6. And this is where a lot of students found it difficult in that exam. They're like, I don't know what sec squared of pi and 6 is, but you got to remember what sec squared represents. What does sec squared represent again? 1 on cos squared. So what this actually means is you got pi and 6 multiplied to 1 over cos of pi and 6 all squared. This is where you must know your exact values. What's tan of pi and 6 again? Go through your hands. Tan of pi and 6? 1 on root 3. Okay, so 1 number of sine fingers divided by number of cos fingers. 1 on root 3 plus, now let's figure this out. What's cos of pi and 6? Root 3 on 2. But remember, you're squaring this. So in the denominator, you're squaring this. What is root 3 on 2 squared? What does that equal to? Come on, what's square of root 3? Yes. Root 3 times root 3, which is root of 9. Root of 9 is 3. Square of the 2, so the square of the numerator, denominator, square of 2, which is 4. So this is where a lot of kids find this problematic, because this is plus pi and 6 times, now you got 1 over 3 over 4. And a lot of kids hate fractions. See, at this point here, it wasn't hard. I've got the formula, I derived it. I put pi and 6 in. It's this point here, 1 divided by 3/4. A lot of students hate fractions. And I screw up here. 1 over 3 over 4 is the same thing as saying 1 divide 3 over 4. And remember, when you do 1 divided by 3 over 4, so 1 divide 3 over 4 is the same thing as saying 1 times 4 and 3. You do the reciprocal. Basic grade 3 and 4 maths, yeah? So that means it becomes 4 and 3. So actually this answer here now becomes 4 and 3. And if you look at the answer, multiply to pi and 6, cross simplify, that becomes 2, 3. So your answer overall is 2 pi on 9. And you leave your answer as 1 on root 3 plus 2 pi on 9. There you go. Okay, so that's what I meant. What were the skills here? They're testing a few things. Product rule. Using product rule of the circular function, exact values, algebra. See? So that's what I mean. That's the first 3 marks, or it might even be 4 marks because of that. The fractions there. Might be a 4-mark question, so method answer, product rule correct, and then arithmetic correct. Could be a 4-mark. 4 out of 40, that's a really nice percentage, 10% for the first question. It's really easy to do. Yeah, that's what I mean. You can't do that. You can see why the weaker 20% of students that are getting below 25, because all these skills, they can't do fractions. You can see why it becomes a problem. You can see if they don't know the exact values, why later on when they're sketching graphs, they're going to get that wrong. You can see why they don't know the product rule, then they can't do chain rule, they can't do quotient. And remember I said 3/4 of your course is based on that. That's why they get below 25. It makes a lot of sense. That's the first question they're hoping to chuck every mark they can, actually. Is that easy? Cool. All right. I'm going to give you the worksheet. I'm going to get you to practice the product rule. Okay, you've got the quotient rule. Have a go. It's the same idea. Work with the quotient rule, and then we'll go through the answers together. Okay? So otherwise, I'll speak on for too long. Here we go. I'll grab out about a half here. Grab one, pass it on. And I'll put it over here. Grab one, pass it on.